answer question number 2A. The question states that the wavelength of a photon emitted in the bracket series of hydrogen emission spectrum in 2.625 nanometer. So if we look at it, we have to label each of the information that we have, and so it will be easier for us. So the wavelength equals to 2.625 multiply 10⁻⁹. Why? Because it's in nanometer. We have to change it into SI unit. So nanometer change it into meter, we get multiply 10⁻⁹. Okay, and then we see that there are a bracket series. From the bracket series, we can point out that actually n final equals to 4, and then we can see that bracket series n final equals to 4 means that electron fall at n is equal to 4. This is actually like n initial and then n final. The last one, the electron fall at n equals to 4. We read the first question. State the region of electromagnetic spectrum of this emission. The region of bracket is infrared. Now we look at the second question. Determine the initial and final energy level corresponding to this emission. We state out the information as I said as before. Initial Ni, final energy Nf. So N final is equal to 4. And then we took a formula. 1 must smaller than N2. So right now we know that N final is the smallest one. So we must put 4 in N1. So we will write it down, substitute the value that we got into the formula, and we got N1 equals to 6. Look at question number 3. It says that calculate the frequency of this emission. Frequency is V. And then frequency formula is C over lambda. Or we substitute the value that we got equals to 1.143 multiplied 1014 as -1. We potong and then we get as -1. Now we look at the question B. Iron has 26 proton number and located at block D. B1. Write electronic configuration for ferrum 2+ and ferrum 3+. And then we write it down. 26 ferrum, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. So in order to write ferrum 2+ and ferrum 3+, we must take out the electron from the highest energy from the outermost shell, which is 4s2. 4s is actually the highest energy, 4. Then we take out, for the ferrum 2+, we take out 4s2 since they donate 2 electrons from outermost shell, and then for the ferrum 3+, we take out 4s2, and since they donate 3 electrons from outermost shell, not only we take it from the 4s2, from the 3d6 we take out 1, then we got 3d5. B2, which of these 2 ions are more stable? Give reason. The first thing that we have to do in order to look at it more clearly is we have to draw the orbital diagram. We draw it, and then you must remember that we have to draw the arrow upward first. For the Fe2+, we filled it upward first until the end, and then we fill it downward. And then for the ferrum 3+, we fill it upward first until the end. And then that's it. We only have 5 electrons, so only 5 electrons in the square. If you look at it, for the ferrum 2+, it's actually partially filled. And for the ferrum 3+, it's actually half filled. Since ferrum 3+ filling pattern more stable because it formed half filled at 3D subshell, then ferrum 2+ filling pattern which partially filled at 3D subshell. Therefore, ferrum 3+ is more stable than ferrum 2+.